Okay, so my name is Andrea Matranga and I made this RGB cube and I'm now going to use it to explain a little bit of subtractive and additive color. This is a prototype, so I had to protect the corners so it looks a little bit less fancy in the corners because it's a little bit shiny. But you know, ideally the final version is going to be clear coated. So there's two types of color. There's additive color mixing and subtractive color mixing. So what we perceive as color is when you have a lot of certain wavelengths of light and not a lot of the other ones. So if every wavelength of light is equally represented, we call that white light. As we start to get a bit more of one wavelength and not of the other ones, we start perceiving color. And when we have a lot of one wavelength and none of the others, that's when we see very bright colors. Okay, so like if the white here, this is reflecting every wavelength that's coming from the light is being reflected at the camera. If we go to blue, that means that only the blue light is being reflected and it is absorbing all of the yellow light. The yellow is the complement. So right away, if you look at the cube head on, these are the opposite colors, are the ones that are on opposite sides of the white. So cyan is the opposite of red. Magenta is the opposite of green, and yellow is the opposite of blue. Okay. Now the two types of colors what you want to get color is a bit of a wavelength and not a lot of the other ones. So you want more of one wavelength than the other ones. And the typical way that this is done is either additively, which means we start from black and then we add wavelengths one by one, green, red, and blue. Or we can do it subtractively, which means we start from every wavelength, which is white, and then one by one we subtract certain of the wavelengths in order to generate color. We want to subtract one wavelength and leave the other ones in. Let's do additive first, which is what you're watching right now. If you're watching this, if you didn't print it out frame by frame, if you're watching this on a screen, this is using red, green, and blue pixels that are being fired in particular patterns to generate the color. So for example, my shirt is yellow. That means you can already see there's red pixels and green pixels. And if I turn both of them on, in between red and green is yellow. So if you took a magnifying glass and magnified the portion of the screen that has my yellow shirt, you would see the blue pixels are not being fired, but the red and green ones are. So the primary colors for additive are red, green, blue, RGB. And you can start from black and add red to get to the red corner. You can add green to get to the green corner, or blue, adding blue to get to the blue corner. Now, if you mix these primary colors, additive primaries, you get the additive secondary colors. So mixing red and blue gives magenta. Mixing red and green gives yellow. This one always is weird to me, but you know, you can try it and it works. And adding cyan and yellow, adding green and blue gives you cyan. Okay, so again, primary additive primaries, red, green, blue. Additive secondary colors, cyan, magenta, and yellow. Now, once you are, in fact, at cyan, now remember, cyan is opposite of red, okay? So if I'm at cyan and then the only color that's missing is red, because I already have the blue and the green primary, that's how I got cyan. If now I add red as well, you see this little R, then that gets us to white, because now you have all three of these primary colors, they're all three equally represented, and we know that when we mix colors in equal proportions, you get the white. And that's the idea of additive colors, such as you use with light, such as screens, for example. Now, the other way of thinking about color or mixing colors is subtractively, as I already said. And that means you start from the white, which is every wavelength, and then you subtract wavelengths one by one. For example, if you had a dye which was incredibly good at subtracting green light, so you start from white and then you put this dye, which is, you can think of it as a filter, in front of the white, and that absorbs all of the green light, but leaves, what are the other two colors? red and red and blue unaffected because it's subtracted of the green light. Well, what's left? If you mix the red and the blue, which is what's left, you took out the green, then you get magenta. So we would call that a magenta dye because you took away the green and what's left is blue and red, which is magenta. Similarly, what's a yellow dye? A yellow dye is something which is really good. What's on the opposite of yellow? Blue. A dye, an ink that absorbs blue, is going to leave the green and the red unaffected. It's only taking out the blue from that white light, from every wavelength. We took away the blue and the red, the blue and the, we took away the blue, but left the green and the red. So what's green and red together? Yellow. And it's the same thing with cyan. That's what you get when you take away the red and leave the green and the blue, which gives us cyan. So those are the three inks you use in subtractive colors: cyan, magenta, and yellow, because those are inks which remove the additive primaries one at a time. And once you have cyan and magenta, then you can mix them, which means you're taking away, with the cyan, what were you taking away? You were taking away the green and the, with cyan, you were taking away the green on this side. You're taking away the green and the blue, okay? And then you mix cyan and you mix, this is because I'm seeing it mirrored, so it's kind of tricky to do it. So if you take away the cyan, you're taking away the green and the blue. If you take away the magenta, then you're taking away the red and the blue, right? Magenta, red and blue, and cyan is the green and the blue. So what did you take away? You took away the red, the green, and the blue, and that means you're going to end up with the black because you took away everything. Now, the other thing that's interesting about the cube is I put the names of the secondary and tertiary color, and there's some things that I didn't know about colors. For example, if you look at this olive color, which most of us interpret as green, and I looked it up, and it's true. So olive is actually a form of yellow. So if you see it's between the black and the yellow, it's when you mix, it's a dark yellow, we perceive that as olive. In fact, it is, it's the same color as canary. Canary is a very light yellow. And if you see, if you could imagine this, this is the canary. The olive is directly beneath it. If we're looking at it sort of like this, up and down, so you see the canary is here and the olive is here. If straight up and down, they're on top of each other. Similarly, the salmon is a light maroon. The maroon is halfway between black and red, and the salmon is halfway between red and white. So salmon is actually light maroon, or maroon is light salmon. Also, the mint green is mint green is light office green. That one's not so surprising. But teal, which is half of green and half of blue and no red, is actually light aquamarine. So one of the things you can do is obviously explain these colors. Another thing that you can do is have a scavenger hunt. So maybe if there's a place with a lot of wildflowers, they can take petals and try to match them on the collar and maybe tape them on them. Or you can give them dots of specific colors, and they have to sort of find where they go on this. Obviously, it's very good for learning names as well. It's a little bit like a globe for learning countries, but for colors. And then there's also a version I'm working on, which would be basically the same, but the difference is, so this is the cube, and it would have, a pattern like this. This is the pattern that made the other cube sort of on it. But it also, so here you would have, right, and this would look like this. It would have white on top, black at the bottom. But it would also open on the equator so that you would have a color wheel. This would have gray in the middle and all the colors going around it. And you could also actually, would be held by magnets, This is a fiendishly difficult puzzle as well. It would be easier with colors on it, but it's pretty hard to put together. That's why I had to tape it. But it would also, let's say, open this way so that you could show a cross section through the cube. You could show various cross sections, and then it could be split into small pieces, and then the kids have to sort of remake it. So that's that idea. And the idea would be, ideally you should have this. You should also have the paints that go with it. The right paint so you can show color mixing, and you should also have red, green, and blue lights. And actually you can use filters, obviously. So this is a filter, blue filter. I can put in front of my light to make blue light. I'm going to turn off this light and close this one. So if I put it in front of the light, I get blue light. Well, you can see you could use something like this to mix colors as well. This is not a particularly high quality filter. Maybe if I do it this way, now in blue. Yeah, this is just a very, this isn't a filter. This is a piece of plastic that was colored. I have to get the proper filter. But you could put pieces of filters in front of it to show how the color changes, to show that you're not just saying it, that you can actually, you know, put a blue and it's going to work. Okay, that's all the time I had. I have to connect to something else. Thanks a lot, and hope to talk tomorrow.